mathematics. How much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
Good morning, grade 11s. So today we are moving on in our unit on light, and we're moving on to light refraction. It is June. Can you believe it? We've made it to June. We have officially 2 weeks of classes left up until June the 12th, which will be the last day any new content will be covered. So realistically, that's 10 classes, of which maybe 7 or 8 will be content toward the end of next week, towards we approach the 12th. The 12th will probably be your final test, where you will have that final week till the 19th to hand it in. And as I've said to some of you, there will be no exam, just a final test on this final unit. And that will be the end of our course. So we've almost made it to the end. We've got a little bit more work to do. And again, I want to thank you for doing the work and for keeping up as best you could. It is a joy to know that you are watching and that you are participating in this form of learning, such as it is. As we get started today, I do want to share with you a verse of the day today, and it's a verse of the day I actually picked for my grade 12 class, because in that class we're starting a unit on planetary mechanics and space exploration and all things outside of what we see here on our Earth. And so Psalm 19, the first 4 verses say the following. And I gotta say, this is one of my favorite passages because I'm a bit of an astronomy buff and I like those kinds of things, and so this passage speaks to me well. Psalm 19 says, "The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge. They have no speech. They use no words. No sound is heard from them. Yet their voice goes out into all the earth. Their words to the ends of the world." And so I always gain encouragement from that, knowing that the heavens declare the glory of God, and knowing that God created all of that in his glory for us to enjoy. And so there you go. All right, refraction of light. So refraction of waves, and we're doing it in the context of light, is the bending of light as it moves from one medium to another. All right, so the bending of waves. I'm going to keep using light because that's what we're going to use. We're going to use a light wave going from one medium to another. So, and that has to happen because we're always in a medium of some kind, whether that medium is air, water, glass, etc. There's always a medium at which light is going through, and it bends. And you can do a quick experiment at home. I don't know if you'll be able to see this on the video or not, but I'm going to try this. If you have a beaker full of water and a pencil or some other thing, and if you put it in here, let's see if this works. Oh, it kind of does. Okay, I'll let that rest there and bring it a little closer. And so you can see that the pencil outside of the water and the pencil inside of the water don't line up perfectly. All right, there's a bending of the light as it went into the water. And so a real quick experiment to see that light does in fact bend as it goes from one medium to another. And you can experience this at home too. If you're ever in a pool, you can look down at your feet and you'll realize that they look closer, you look shorter when you're standing in water looking down. If you've ever fished, you know that light bends as it moves from one medium to another. And so I've drawn a quick diagram here, and this was supposed to say glass. What we have is we have a light ray traveling down here, striking the edge of a glass block, going through the glass block and then going back into air. And so every time that light travels from one medium to another, it will be bent. So here we have an angle of incidence, but we'll call this angle 1. All right, again, we have our normal line drawn here, and angle 1 is measured from the normal line to the ray. As it goes into the glass, you can see here that the angle of refraction is smaller. It has been bent towards the normal line. Okay, and then Oops, this is the wrong notations here. Angle 2 and angle 1. All right, and so again, now when it hits the normal line here as it leaves the glass, again we have an angle, but it's going to be equal to angle 2. And again, this is a geometrical formula where we have two parallel lines and a line that crosses them. The interior angles are going to be equal, the opposite interior angles are going to be equal, and so we have that happening, and on the outside, again, we have it bending away from the normal line, and again, the two outside angles will be equal in this case. So that's how light bends, and it does this every time it goes from one medium to another medium. A scientist by the name of Snell studied this and was credited with the law on this, and basically he said exactly that as light travels from one medium to another, it will bend. And from Snell's law, we came up, there's a formula that has been derived, and that formula is this. It is N1 times the sine of theta 1 equals N2 times the sine of theta 2. Make that 2 nicer. Okay, now you might be asking, what is N? Well, N is an index of refraction. And so through study, we've developed indexes of refraction. And an index of refraction is a ratio of the incident angle, the sine of the incident angle over the sine of the refracted angle. So here we have incident and refracted. If we took the sine of those and divided them, we'd get a ratio. And that ratio is considered to be N. And every medium has a specific N. And so if you go to page 486 of your textbook, there's a chart of indexes of refraction. Indexes of refraction. And you will see there that in a vacuum and in air, the index of refraction is 1, and then as we move into various other materials, the index changes. So for instance, water has an index of refraction of 1.33, glass 1.52, diamond 2.42, and so forth. And so when you get questions, you're going to need to refer to page 486 for the indexes of refraction for your N. All right, so any question that you could get would simply say, light travels from air into glass. The incident angle is 30 degrees. Find the refracted angle. All right, so you're going to look for your air index. You'll have your incident angle. You'll have your glass index, and then you're going to want to find your refracted angle. All right, and we'll do that question right away on the other board, and you'll be able to see how the math works there, and then you'll get a few questions on this, and our goal in this is to move to some lens properties and how images are formed using lenses, so we'll get there in a couple of days. All right, we're going to leave it at that for today. I'm going to give you an example on the other board first, so let's go do that before we get going. All right, here's the example that we were just talking about. We have a light beam hits a block of crown glass at an angle of 30 degrees. At what angle is the light refracted? If you are looking for angles of refraction, you will be using Snell's law. So we will start by writing Snell's law down. N1 sine theta 1 equals N2 sine theta 2. All right, and again, when we talk about 1s and 2s, this is medium 1, so where is the light coming from? So in this case, air, and where is it going into? In this case, crown glass. All right, we have air and crown glass. We're going to go to our chart on page 486, and we see that the index of refraction for air is 1.0003. We can call that 1. Okay, and we see that the index of refraction for crown glass is 1.52. That gives us all the information we need. So we're going to start filling this in here. We're going to go 1.0 for the index of refraction for air. We have the sine of 30 degrees equals to 1.52 times the sine of theta 2. And of course, it's sine of theta 2 that we want to solve for. So we're going to divide both sides by 1.52. Cancels that out. We will punch this into our calculator, which will give us a number. And then we have to take the inverse sine. Remember, we're going to have this decimal equaling sine of theta. And to solve for theta, you have to take the inverse sine of that. And when you do that, making sure your calculator is in degrees, of course, the mode, and you're going to get theta equals to 19.2 degrees. All right, and so when we're working with this, it's going to be as simple as this with every question, but you're going to have to remember a couple of key things. First, you're going to have to remember the formula. Second, you're going to have to remember that there's a chart on page 486 where you will find the indexes of refraction. All right, so some questions will give you the indexes of refraction. Some questions will tell you what the medium is, and if there's no index given and you need it, find the chart on page 486. All right, we're going to leave it at that for today. You'll get a short assignment out of your textbook. You can find that on Connect, and we will see you tomorrow.